Okay, in this last video, we go over simple linear regression. And again, keep in mind is that for this class, this is the only type of regression that we're going to cover, but regression can extend to multiple regression, nonlinear regression, logistic regression. It is the foundation for a lot of different more advanced analysis, but this is a great place to start. What we're trying to do with simple linear regression is predict one variable based on another. It is where we think that one variable would cause another one to happen. And we're going to assume a linear model. So we're going to build a model, a math model, based on the equation of a line. So we want to be able to take some data and be able to from the data, generate a slope and an intercept. And then we measure if it's a good model based on the correlation coefficient squared, which is called the coefficient of determination. Or if you don't want to remember that, just remember correlation coefficient squared. It does have an interpretation, though. It measures the amount of variability accounted for. So if you have an R squared of 0.6, that means 60% of all the variability is accounted for in that model, and only 40% remain. And that's good information to know. In Excel, the easiest way to generate a math model is from scatter plot data. So if we can build a scatter plot, and remember the name of a scatter plot is called an XY chart. So if we grab data in the form of an XY, it will generate a scatter plot for us. We can also use these equations slope, and where we grab the Y data first and then the X data, same thing for the intercept. Notice that the arguments, you have to grab the Y data first and then the X if you're going to use the Excel formula. So let's do an example. Same thing, we're going to use the 1976 NFL football data, and we're going to try to predict our wins, how many wins I think a team would have as a function of how good our defense is against the run. Now keep in mind, what I'm trying to do is build something that theoretically makes sense. I think that my wins could be a result of how well my defense. It's not the other way around. I'm not going to say that I'm going to win a game and then hopefully that will make me have a good defense, because it doesn't work that way. You have to establish and have a good defense. You don't win the game first. You have a defense first. And think about all the things that go into developing a defense. All of that happens before you win or lose a game. So it does make sense theoretically, at least from a time standpoint. Defense happens before wins, so it makes sense to have a model. And I'm going to put some data together and let it generate the slope and the intercept. Then I'm going to answer the question, is it a good model, by looking at my R squared, and then I'm finally going to predict the number of wins. So here's the data, and the two columns I'm interested in are games won, which are going to be my Y's, against my rushing yards allowed. So I'm going to go ahead and grab this data and move it over. Same thing on this one. I'm going to grab this data and move it over. Just made copies of them. I'm going to scroll over a little bit now. So that is my X, that is my Y, and first thing I'm going to do, and notice I put my X to the left. So the X-axis, X data is in the column L, and then the Y is on the right side of it. I'm going to grab the data, right-click. After I've got it grabbed, and I'm going to go under Insert, and I'm going to build a scatter plot. And I'm not going to use the lines. That you don't want to attach them unless they're ranked. I'm just going to get the dots. Okay, there you go. Now this is developed, and notice what happened is the Y-axis are my wins. That's my result. Also called my dependent variable. This would be my dependent variable. And then X is what I can control. It's the cause, also called the independent variable. dependent variable, independent variable. I guess we could put a axis on this. Let's add an axis title. This is my dependent variable. This is my independent variable. We always plot the independent variable on the horizontal axis or the x-axis and the dependent variable on the y-axis. So there, and you can see that there is somewhat of a relationship. The more yards you give up, the fewer games you win. The less yards you give up, so it's an inverse relationship or negative relationship. But now I'm going to build the equation. And there's a couple ways to do it. One way to do it from a scatter plot is right-click on one of the data points, right-click, and then it says add a trend line. This form pops up. The default is linear, which is what we want. I'm going to scroll down a little bit. I'm going to get the equation. I'm also going to get the r squared. So there you go. So that is my regression equation, where the minus 0.0062 is my slope, the 20.258 is my intercept. If this axis would go up to, let's say up to 25, just because, where this dotted line would cross the y-axis is around 22. That's what, or 20.258. That's what that means. The slope means that for every yard that I give up, the chances of winning drops by minus 0.0062. So the reason that is a small number, the minus 0.0062, is that the math has to translate yards into wins. Yards are in the thousands, wins are in the tens, and you have to, that's the cool thing about regression, is that it will translate that for you by giving you this scalar, which is a very small number. So just because it's a small number don't mean it's not important. It just means that it has to map a big number into a small number. The other thing we get is our r squared. And remember the definition of r squared. This is the amount of variability accounted for it. So I can say that 43% of the reasons that I win a game is because how my defense does against the run. Now, that's an incredible amount to know, just like that, of 100% of the reasons I would win a game, 43% of it is accounted for with my defense against the run. You're never going to know 100%. But if you can get, once you start putting these together, you certainly know that your defense against the run is important. And that's something that you need to manage. And again, that's what we want to use stats for, is to use it to make decisions. And we're learning some things about that. So let's show you the other way to do it. Let's calculate the slope and the intercept using Excel formula. Equals slope Notice it wants you to grab the y's first, so the order is important. I'm going to grab the y's. You separate them with commas, and then I'm going to grab the x's. And that's the same number. Same number. Same thing with the intercept. Grab the y's first. Separate them with a comma. Grab the x's. If you don't do it in that order, you'll get a different answer. And there's the intercept. So we can build a model. So if I can say if x equals, and I'm just going to put a placeholder there now, 3,000, these are yards, then y equals the slope times x plus my intercept. There's my math model. My slope times my input of x plus my intercept. So that's how many yards. So let's use that to go over here and predict the number of wins if my rushing yards equals 2205. Now there's a couple ways to think about doing this. One thing I could do is look at this and say, wow, well, That team, which happens to be the Washington Redskins, they gave up 2,205 yards and they won 10 games. So that's my answer, because that really happened. Washington Redskins gave up 2,205 yards. They won 10 games. So I ought to just say 10. The problem with that is you're only using one data point. That's classic anecdotal data. When you rely on one data point and don't look at all of the data, that is a great way to misinterpret or improperly use statistics. It's just anecdotes. And as people, we tend to remember unique, interesting things. We don't remember the monotonous things that happen most often. So we'll remember the exceptions. So don't do that. We don't want to just say and look for experience, because look down here. The Washington Redskins gave up 2,205 and won 10 games. But if you just go down just a little bit, you can see that the New York Giants gave up actually 3 yards less and only won 3. So we don't want to use that. We want to use the model. Let's put this in, 2205. And it says the number of wins is about between 6 and 7. So it's not this. That would be way overestimating. Now, there might be other reasons that the Redskins won the game, but it wasn't because their defense was good. And this helps you tease that out, and what is the impact of the defense for your impact on wins. Okay, that's how you can use Excel to do simple linear regression. Thanks.